Welcome to today video lecture series on topic heat transfer applied to aerospace engineering is ablative heat transfer. So ablative heat transfer is the definition is the process of removing hot from a heat from a material by vaporizing its surface and quickly removing the gas. And the importance of this phenomena is particularly important in environments where materials are exposed to extreme heat, such as during atmospheric re-entry of spacecraft, rocket propulsion, and in various industrial applications. And the key parameters is this removal of material helps dissipate heat, protecting the underlying structure. And heat transfer mechanism is a heat conducts through the material to the surface. Convection is in some applications, convective heat transfer can assist in cooling. And radiation at high temperatures, thermal radiation can also contribute to heat loss. And types of ablative heat transfer is charring. So charring is a process that occurs when a solid material is partially burned by heat, removing hydrogen and oxygen from to form a carbon-rich residue. And melting and evaporation, materials are melted in this process, creating transition to a liquid state and then evaporate, removing heat in the process. And sublimation is the phase transition that occurs when a solid material turns directly into a gas without passing through a liquid state. Now, ablative heat transfer is advantageous. Its materials can withstand extreme temperatures, prevents overheating, materials are lightweight. Some ablative materials form character layers that insulate and protect the underlying material from further heat exposure. So disadvantages is continuous ablative results in material degradation, limited lifespan, complexity in design. And applications of ablative heat transfer is spacecraft reentry, and ablative materials protect the vehicle from the intense heat generated during atmospheric re-entry by dissipating heat through ablation. Rocket nozzles, some rocket engines utilize ablative cooling, where the nozzle material erodes to absorb heat from the combustion gases, thus preventing overheating. And thermal production system, these systems are preventing to endure high temperatures while minimizing damage to underlying structure. And conclusion is ablative heat transfer works by leveraging the physical and thermal properties of materials to protect against extreme heat. By removing material through ablation, heat is effectively dissipated, safeguarding critical components in various high temperature applications. Understanding this process is essential for the design of effective thermal production systems in aerospace and other industries. So in this conclusion, this image will represent about the ablative heat transfer mechanism in aerospace engineering. So in this in this image, the oxidizer from pump and injector are here, and the nozzle and heat exchangers are also here, and the fuel pump also it will be in the downward section. So this is the combustion chamber. So basically, we know about the combustion chamber is having the three types is annular, can, and can tubular also. So in this heat exchanger parameter mechanism, the applications of the oxidizer pump injector, heat rejector, and a combustion chamber with two movement about the working of the combustion chamber. And in this image, we'll explain about the some sandwich panel section in the top word, it will be located in the heat flux, and bottom section, it will be in the base structure of the aluminum and the titanium alloy section. So it will be the limited lifespan with for the complex design and the material safety equipment for the further process. So this is the video lecture about the ablative heat transfer in aerospace heat engineering and its applications. Thank you.